Well, behind me, I was working with the number 10 power minus 19 and wanting to write that as 0.000 and so on and so forth. But yes, it goes on forever. So that led me to think that we need to start learning exponents. So what are exponents? Just like logarithms, exponents help us write very small numbers and very large numbers in an easier way. By the way, if you want to learn more about logarithms and how they work with exponents, I have made videos on my channel, Spot On with Shruti. So please be sure to check out those logarithm videos if you would like. All right, coming back to exponents. So on exponents, as I was mentioning, if we wanted to measure the size of a very tiny subatomic particle or the distance of an extra or a celestial body in outer space from our planet Earth, then we utilize exponents. And how we do that, this video is going to cover all of that. So on this one, I'm going to give you a basic idea of what an exponent is, what are the exponent rules and laws that are commonly utilized to solve any kinds of problems, and most importantly, if you out there are attempting A.C.T and S.A.T math, then exponents is a sure guaranteed topic. You can definitely expect one question, if not more, on exponents. So please be sure to go over this video and get your concepts honed in good so you can get at least that 1 point added to your total score. So without any further delays, let's go ahead and get started. See you around. Okay, so let's go ahead and get started. As you can see on the screen, I have written some examples: 5 times 5, 5 times 5 times 5, and then an example with 3. So the idea is when we multiply 5 2 times, we get 25. 3 times, we get 125. And if you multiply 3 4 times, we're getting 81. But these are simple numbers to work with. These numbers can get up to, like, you keep multiplying for n number of times. So there is an exponential notation that we utilize, and that's where we write these numbers. Like first one, for example, can be written as 5 and to the exponent of 2. 2 meaning number 5 has been multiplied 2 times. Same way, 5 cube or 5 to the exponent of 3, which means the number 5 has been multiplied 3 times, and so on and so forth. So the basic idea is if you take any number a, that number a is called the base number, and the power to which the number of times a number is multiplied is called the exponent. And oftentimes these days, it is also interchangeably used with the word power. So exponent or power. But traditionally, when we discovered exponents, it was referred to as exponent. But it's all right if you want to utilize the word power as well. So now, how do we utilize exponents? We utilize some rules and laws to help solve some problems. So I'm just going to give you a brief summary of what those rules and problems are going to be. So let's go ahead and get started with that. So first and foremost, if there is, for example, any number a, and it has an exponent of m, and we're multiplying it with another number, which is the same number a, but it has another exponent n. As an example, we can take, if it is 3 power 2 times 3 power cube, then if it's a multiplication, now provided the condition is the number that we are multiplying is the same, the base is the same, then the exponents get added. We just add the exponents. 3 to the power of 2 plus 3, which is 3 power 5, and then you key it into your calculator to get your answers. Same way, we have a division or a quotient rule where we have the same bases and we are dividing them. So as you can see on the screen, the number a, the base is same, only the exponents are different. So again, you can take an example of 3 power 6 over 3 power 2. And here, in this case, when that is a fraction, we subtract. The exponents get subtracted. So this is 3 power 6 minus 2. Another common example is when we have a base number, it has an exponent m, put it in the brackets, and then there is another exponent outside of the bracket. In this scenario, we actually multiply these exponents and rewrite the number as a to the power of m times n. So for example, if we have something like 4 squared and a 3 outside of the bracket, so this will be in return 2 times 3 in the exponent. okay, and it becomes 4 power 6. So basically exponential rules are self-explanatory and they're very easy to understand. All right, moving on. What if we have a negative exponent? For example, we have the base number a, but we have something like a minus m. Then all that we have to do is take the reciprocal of the base and your exponent remains the same but with a positive sign. So for example, if we had 3 power minus 4, we will rewrite that as 1 over 3 power 4 and vice versa. Important point, all exponential rules can work vice versa. So on this one, if we had something like 1 over 3 power minus 4. So again, if you wanted to change or convert the negative to the positive exponent, you will take the reciprocal of the number, which is the base number is 1 over 3 here. You will rewrite that as 1 over 3 power minus 4. And then you take the reciprocal and it becomes 3 power 4. All right, get the idea here? Okay. Also, another important point that I'd like to mention is while solving any exponential problems with negative exponents, it is recommended and a good idea to convert the negative exponent into a positive exponent. And we utilize this particular property right here. All right. Another one is if we have fractions or radicals. For example, if I had a square root of 3, then this is written as, actually, let's understand the square root of 3. Square root of 3 has the number 2 here, right? So we write that as a fractional exponent and vice versa. So for example, if it was 4 power 1 over 3, so you will put the radical symbol, the index is 3 for this and 4 goes inside. If this was 5, 2 over 7, then we will write the 7th root of 5 squared under the radical. That's the way we work with it. Now, what if these came with negative exponents? Let's take another example. 6 power minus 2 over 7, for example. So you see there's a negative exponent. So first and foremost, we take the reciprocal of the base number, 1 over 6, that becomes 2 over 7. And then you can work with the exponent, the fractional exponent, and write that as 7th root of 6 squared, and so on and so forth. So these are the simple exponential rules. 2 more to go. One is if there's a base number a and it is raised to the power of 0, the answer is always going to be 1. Okay, so what does that mean? Basically, the idea is very simple. If you just take this as a simile, like if you wanted to make copies of a certain page or a sheet of paper, and you make 0, exponent is the number of copies you're making. So if you make 0 copies, you're left with the same copy you started off with. If you're making more than 1 copy, and that's the exponent, right? So a power 0 will always be 1. For example, if I write 2 power 0, anything raised to the exponent of 0 is going to be 1. If I write 3 times 2 times negative 1 over 6 to the power of 0, that will also be 1. You write any kind of gibberish in the bracket and raise it to the exponent of 0, answer will be 1. Okay, a very neat little idea and a very helpful law as well. Another one is if we have anything to the power of 1, of course we know anything to the power of 1 is always going to be that number itself. All right, so anytime, now let me ask you this, if we raise, like going back to the previous one, 0 to the power of 0, what is that? Do you think that is going to be 1? No, that is not going to be 1. Because if you have nothing in your hand and you're trying to make copies of nothing, what are you left with? Nothing. So the answer is not 1 for 0 power 0, that answer is going to be 0. So another important idea. So here is a summary, as you can see on the screen, and there's a chart, and you can take a screenshot of this if you would like, for the exponential rules, wherein I have summarized everything. And that brings me to the end of this video. I'll make another one with some examples that will help you solve some mathematical questions and equations, especially the ones on A.C.T and S.A.T math with exponents. All right. So if you've liked this presentation and or you want to book some sessions with me, my information has been provided for your reference. I would surely be happy to look forward to hearing from you. All right. Okay. See you on the next one. Bye-bye.